If you recall, in Calculus 1, one fact about the derivative is that it allowed us to approximate a function with a line. Now, line makes you think of linear, and if you've taken linear algebra, you know that in linear algebra you worked a lot with matrices. And that's because matrices represent these things called linear transformations. And what we're going to essentially do in vector calculus is just like we used a derivative to approximate a function with a linear function, we're going to use the derivative in this multivariable case to approximate a function with a linear transformation instead. So let's just remind ourselves what we're saying when we say that a matrix represents a linear transformation. So let's have the matrix A equals 1, 2, 3, 4, 5, 6, and we'll have B equal 7, negative 8, 9, negative 10. The matrix A, we can think of, we can use it to define a vector valued function given by the product of this matrix with a two-dimensional vector. So we'll have something like x1, x2. Because this is a 3 by 2 matrix, and this is a 2 by 1 matrix. So when we take this product, we should get a 3 by 1 matrix. The specific 3 by 1 matrix we get is going to be x1 plus 4x2. Then we're going to have 2x1 plus 5x2. Then we'll have 3x1 plus 6x2. What that essentially says is that the vector valued function f takes x1, x2, and returns the multi-valued function x1 plus 4x2, 2x1 plus 5x2, and 3x1 plus 6x2. So we are allowed to use matrices to represent these kinds of linear functions. And when we say linear, what it means is that we don't have any exponents greater than 1 here. So that's kind of the key thing. There's going to be a couple caveats when we get to actual derivatives, but we'll get there when we get there. We also, another key fact about these things, let's say that B was represented by the function g of x is B times the vector x. Well, if you take the matrix A, B, that gives you a new matrix. What does that matrix equal? Well, we can do some little multiplication. That's going to be 7 plus, oh goodness, 36, so that's going to be 43. That's going to be negative 8 minus 40, that's negative 48. Then we're going to have in our next row, 2 times 7 is 14, 5 times 9 is 45. Who made this? I think that's 59. That's negative 16 minus 50, that's negative 66. And then that's going to be 21 and 63, that should be 84. Andrew from the future, I did not trust my mental math. I was in fact wrong. This was indeed 21 plus 54, which is 75. Sorry about that. It will be incorrect for the rest of the video, but it doesn't matter that much. And then we'll have negative 24 and negative 60, so that's going to be negative 84. Oh, that seems surprising. So that gives me a new matrix. What does that matrix mean? Well, AB, if we multiply that by a vector x, that is the same as composing the function f with the function g. And that's why matrix multiplication is defined as weird as it is, because it allows us to find the composition of two functions, of two linear maps, just by multiplying the matrices together. And that's something we are going to see later on in this course as we work with our derivatives. So stay tuned for that.